Hello students, welcome to the EduSet program. Myself Dr. Raman Rani Mittal, lecturer in chemistry from Government Polytechnic College for Girls, Patiala. Today I am going to deliver you a lecture on solutions and mole concept. This topic is taken from the first semester class of all the diploma courses. The main contents of this chapter under the heading mole concept, which we are going to cover, are atomic and gram atomic mass, then molecular mass and gram molecular mass, mole concept and its importance along with numericals. In solutions, we will study solutions and methods of expressing the concentrations of the solutions. Now, we will study first of all mole concept. All of you know that matter, it is made up of atoms and molecules, or we can say atom is the ultimate particle of matter. Naturally, mass of matter is due to atoms and molecules, and mass of an atom is called as atomic mass and mass of molecule is termed as molecular mass. Atom is so small that actual mass of an individual atom or molecule cannot be expressed in grams, it cannot be determined. So, to express the masses of atoms and molecules, the unit which is called as atomic mass unit, it is abbreviated as AMU is introduced. So, what is atomic mass unit? The atomic mass unit is the 1/12 of the actual mass of an atom of carbon atom C12 isotope. Means what is the mass of carbon atom? Its 1/12 is called as the atomic mass unit. So, on the basis of this we can define atomic mass in terms of, or we can say atomic mass is a relative atomic mass. So, it is how many times an atom of the element is heavier than 1/12 of an atom of carbon, which is C12. So, mass of an atom of an element, it is divided by 1/12 of the mass of an atom of carbon. In actual, mass of an atom of carbon is 12 and its 1/12 will be 1. So, atomic mass is equal to mass of an atom of an element. For example, atomic mass of oxygen atom is 16 AMU. It means an atom of oxygen is 16 times heavier than the 1/12 of the mass of the carbon atom. Similarly, we can say masses of other atoms. Mass of hydrogen is 1 AMU. So, it is 1 times heavier than 1/12 of the mass of the carbon atom. The atomic mass of an element is the average relative mass of its atoms as compared with an atom of carbon taken as carbon as 12 AMU. So, now we come to the gram atomic mass. Gram atomic mass is the quantity of an element whose mass in grams is numerically equal to its atomic mass, or in simple words we can say atomic mass of an element when it is expressed in grams is called as gram atomic mass, or it is also termed as gram atom. For example, the atomic mass of oxygen is 16 AMU, then gram atomic mass of oxygen is 16 gram, atomic mass of nitrogen is 14. So, gram atomic mass of nitrogen will be 14 gram. Similarly, for the other atoms, whatever is their masses in AMU when they are expressed in grams, so that will be their gram atomic masses. So, gram atomic mass is also called as gram atom. So, number of gram atoms will be equal to mass in grams and it is divided by gram atomic mass. We will be able to calculate the number of gram atoms present in the given mass. The definition of molecular mass of a substance which is may be compound may be defined as the average relative mass of a molecule of that substance as compared with the mass of an atom of carbon 12 taken as 12 AMU. Same is the definition for molecular mass. Here instead of atom we will use the term molecule, or in other words we can define molecular mass as to how many times a molecule of the substance is heavier than the 1/12 of the mass of an atom of carbon. Same is the definition as we have studied just now for atomic mass, that how many times a molecule is heavier than 1/12 of the mass of an atom of carbon. So, for example, a molecule of carbon dioxide is 44 times heavier than the 1/12 of the mass of the carbon atom. Hence, molecular mass of carbon dioxide is 44 am. Similarly, a molecule of water is 18 times heavier than the 1/12 of the mass of the carbon atom. So, molecular mass of water will be 18 amu. How to obtain molecular mass? The molecular mass is obtained by adding together the atomic masses of various atoms present in a molecule. For example, the molecular formula of carbon dioxide is CO2. So, its molecular mass can be calculated as we will adding the atomic masses of all the atoms present in this carbon dioxide. So, this is equal to atomic mass of carbon plus 2 into atomic mass of oxygen. Why we have multiplied it by 2? Because in carbon dioxide there are 2 oxygen atoms. So, 2 into atomic mass of oxygen. So, atomic mass of carbon is 12 plus 2 into 16, because 16 is the atomic mass of oxygen. So, 2 into 16 is 32 plus 12. So, this comes out to be 44 AMU. So, molecular mass of carbon dioxide is calculated as 44 AMU. So, now we come to the definition of gram molecular mass. Same as for atomic mass, the gram molecular mass is the quantity of a substance whose mass in grams is numerically equal to its molecular mass, or in simple words we can say molecular mass of a substance when it is expressed in grams is called as gram molecular mass, and it is also called as gram molecule. So, we can say that what is gram molecular mass? Molecular mass which we write in AMU when it is expressed in grams. So, that will be called as gram molecular mass. So, for example, once again take the case of oxygen. The molecular mass of oxygen is 32 AMU, and therefore, its molecular mass is 32 gram. Same thing applies to all other examples. If you take the example of nitrogen, molecular mass of nitrogen is 28 AMU, its gram molecular mass is 28 gram. Molecular mass of water is 18 gram, molecular mass will be 18 gram. So, as I have told you just now, gram molecular mass is also called as gram molecule. So, we can calculate the number of gram molecules by dividing mass in grams divided by gram molecular mass. Now, let us take the example in numerical form, that calculate the molecular mass of calcium carbonate. Solution: molecular mass of calcium carbonate, its formula is CaCO3. So, in this molecule we have 3 types of atoms. We will add the atomic masses of all the atoms. So, number of calcium atoms, they are 1. So, 1 into atomic mass of calcium plus 1 into atomic mass of carbon plus 3 into atomic mass of oxygen, because number of oxygen atoms are 3. So, you must know what is atomic mass of calcium. Atomic mass of calcium is 40. So, 1 into 40 plus atomic mass of carbon, it is 12, plus 3 into 16, because atomic mass of oxygen is 16. So, 40 plus 12 plus 48, because 3 into 16 it is 48. So, 40 plus 12 plus 48, the total comes out to be 100 AMU. So, molecular mass of calcium carbonate is 100 AMU. Similarly, we can calculate the molecular masses of other molecules. It may be sodium hydroxide, it may be sulfuric acid, it may be glucose, any other case. So, simply we have to add the atomic masses of all the atoms present in the molecule. Now, we come to the mole concept. As in daily life we use a term dozen. Dozen means 12 articles. So, but in chemistry we use a unit mole to count the number of particles. It may be atoms, ions, molecules or any other thing. So, a mole is a collection of 6.023 into 10 raised to 23 particles, irrespective of their nature. So, this number 6.023 into 10 raised to power 23 is called as Avogadro's number, and it is denoted by N naught, capital N naught, or we can say simply in terms of numbers, 1 mole is equal to 6.023 into 10 raised to power 23 particles. So, let us take the example. 1 mole of atoms means 6.023 into 10 raised to power 23 atoms. We have to mention when we are describing molecules, 1 mole of molecules 6.023 into 10 raised to power 23 molecules. Similarly, 1 mole of ions, same number of ions 6.023 into 10 raised to power 23 ions. We can mention 1 mole of electrons, 1 mole of protons, same is the number 6.023 into 10 raised to power 23 proton. Here we have written 1 mole of atoms, but if we are to describe what type of atoms, for which element we are asking, we are talking, while using the term mole, it is important to indicate the kind of particles involved. 1 mole of H atoms, because here I have written 1 mole of atoms, but when we are talking about hydrogen, so we will have to mention 1 mole of hydrogen atoms, that will be equal to 6.023 into 10 raised to power 23 atoms of hydrogen, and 1 mole of H molecules, hydrogen molecules means 6.023 into 10 raised to power 23 molecules of hydrogen. So, you must be now quite familiar with the term mole, that 1 mole is equal to how much number. Now, this is the relationship between mole and the number of the particles. Mole is also related with the mass of the substance also. So, what is that relationship? We will study one by one. Mole and gram atomic mass. You have studied gram atomic mass also and mole also. So, we will study now the relationship between the two. Mass of 1 mole of atoms of any element in grams is equal to its gram atomic mass or 1 gram atom. This is you are knowing that gram atomic mass is also called as 1 gram atom. So, 1 mole of atoms, this is equal to 6.023 into 10 raised to power 23 atoms. Also 1 mole of mass of this 1 mole of atoms is also equal to gram atomic mass of the elements. For example, mass of 6.023 into 10 raised to power 23 atoms of oxygen is 16 gram, because the gram atomic mass of oxygen is 16 gram, and this is also equal to 1 mole. Now, relationship between mole and gram molecular mass. mass of 1 mole of molecules of any substance in grams is equal to its gram molecular mass. 1 mole of molecules by number 6.023 into 10 raised to power 23 molecules, and this is also equal to gram molecular mass. So, let us take the case of sulfur dioxide. Sulfur mass of 6.023 into 10 raised to power 23 molecules means 1 mole of molecules of sulfur dioxide is equal to 64 grams. Similarly, mass of 6.023 into 10 raised to power 23 molecules of carbon dioxide, which is 1 mole, that is equal to 44 grams. 44 grams is the gram molecular mass of carbon dioxide. So, we can say 1 mole of molecules, mass of 1 mole of molecules is equal to its gram molecular mass. Similarly, there is a relationship between mole concept for ionic compounds. Mass of 1 mole of formula units of any compound. For ionic compounds, we do not use the term molecule, we use the term formula units. So, mass of 1 mole of formula units for any ionic compound in grams is equal to its gram formula mass. So, here instead of using the term gram molecular mass, we will use the term gram formula mass. So, 1 mole of formula units is equal to 6.023 into 10 raised to power 23 formula units molecules. This is equal to gram formula mass. So, mass of 1 mole of NaCl formula units, 1 mole of NaCl formula units are 6.023 into 10 raised to power 23 formula units, or it contains this much number of ions and this much number of chloride ions is equal to 58.5 gram, or 1 this is also termed as 1 formula mass of NaCl. Gram formula mass for an ionic compound is also called as 1 formula mass. So, for gaseous substances, we use we measure the amount of gaseous substances in by volume wise. So, here we will have a relationship between mole in terms of volume. So, 1 mole of any gas at STP, STP is the standard temperature and pressure. What are the standard temperature and pressure? 0 degree Celsius or 273 Kelvin and 760 mm of pressure. So, when these are the conditions, the conditions are called as the STP or NTP conditions. So, 1 mole of any gas at STP occupies a fixed volume, that volume is 22.4 liters, and this volume is also known as the molar volume. So, we can study it by taking 2-3 examples of different gases. 1 mole of hydrogen gas, H2 gas, whose molecular mass is 2 grams, it will have a volume at STP equal to 22.4 liters. 1 mole of nitrogen gas, that is N2 gas, its molecular mass is 28 grams. So, it will have volume 22.4 liters. Similarly, 1 mole of oxygen gas, whose molecular mass is 32 grams. So, it is also having the same volume. Same is the for carbon dioxide, whose molecular mass is 44 grams. So, 44 grams of carbon dioxide will occupy 22.4 liters of gas at STP. So, these volumes at STP, they are called as the molar volume, because this is the volume occupied by 1 mole of any gas at STP. So, we generalize the things. 1 mole of any gas, that is equal to 22.4 liters at STP. This 1 mole of a gas is also equal to 6.023 into 10 raised to power 23 molecules. 1 mole of a gas is also equal to gram molecular mass. So, once again take the case of hydrogen gas. 1 mole of hydrogen gas is equal to 22.4 liters at STP. 1 mole of hydrogen gas is equal to 6.023 into 10 raised to power 23 molecules of hydrogen, means this much number of molecules of hydrogen are present in 1 mole, and weight wise 1 mole of hydrogen gas is equal to 2 gram. So, we can calculate the number of moles if we are given the masses for elements. Number of moles is equal to number of atoms divided by Avogadro's number, which is 6.023 into 10 raised to power 23. Similarly, if we are given the mass, we can convert that mass into the number of moles, mass of the atom, mass of the element in grams divided by its gram atomic mass. So, here we can have a numerical, calculate the number of moles in 22 grams of carbon dioxide. So, we have a solution for it. Molecular mass of carbon dioxide is 12 plus 2 into 16. This is calculated here once again. 12 is the atomic mass of carbon and 16 is the atomic mass of oxygen. There are 2 atoms of oxygen. So, 2 into 16, this comes out to be 44 AMU. So, molecular mass of carbon dioxide is 44 AMU. So, as you know that molecular mass, when it is expressed in grams, it is called as gram molecular mass. So, gram molecular mass of carbon dioxide is equal to 44 gram, and gram molecular mass of any substance is equal to 1 mole. So, we will have equation here that 44 gram of carbon dioxide, they are equal to 1 mole. So, therefore, 22 grams of carbon dioxide will be equal to 18 upon, this will be equal to 1 upon 44 into 22, this will be equal to 0.5 mole. So, for compounds, number of moles can be calculated either from number or from mass. So, number of moles will be equal to number of molecules of the compound divided by Avogadro's number. If mass is given, we can calculate the number of moles from mass of the compound in grams divided by gram molecular mass. And for an assembly of things like formula units, number of moles can be calculated from number of things, given number of things divided by Avogadro's number, and we can say 1 mole is equal to gram molecular mass equal to Avogadro's number. This is equal to 22.4 liters at STP for gaseous substances. Now, we come to the importance of mole concept. The mole concept can be used to calculate variety of things. So, first of all, it is used to calculate the mass of one atom or any other number of atoms of the element present in the given mass. So, mass of an atom of element, this is equal to, the formula is gram atomic mass divided by Avogadro's number. So, definition by statement we can say that this much gram atomic mass is present in this much number of atoms. So, given mass will contain how many number. So, we will have this formula. So, we can have the numerical here, what is the mass of single atom of hydrogen. So, atomic mass of hydrogen is equal to 1.008 AMU, and this is equal to its gram atomic mass. So, gram atomic mass of hydrogen will be 1.088 gram. Now, as this gram atomic mass is equal to 1 mole, that is equal to 6.023 into 10 raised to power 23 atoms. So, we can equate it that 6.023 into 10 raised to power 23 atoms of hydrogen will have mass 1.088 gram. Hence, single atom, one atom of hydrogen will have mass 1.088 divided by Avogadro's number. This comes out to be 1.66 into 10 raised to power minus 24 gram. So, this is the mass of one atom of hydrogen in grams. So, if we have to calculate the mass of other hydrogen atoms, other number of hydrogen atoms, so it may be 10, it may be 100, it may be 500. So, we can multiply the mass of single atom by that number. So, suppose you are going to calculate the mass of 10 atoms of hydrogen. So, we will multiply 1.66 into 10 raised to power minus 24 into 10. So, that will be the mass of 10 atoms of hydrogen. So, we can have another example, that what is the mass of single atom of carbon. So, first of all you must know the atomic mass of carbon. Atomic mass of carbon is 12 AMU. Gram atomic mass, of course, it will be 12 gram. So, we will have equation that 6.023 into 10 raised to power 23 atoms of carbon have mass how much? 12 gram. So, single carbon atom will have mass 12 upon 6.023 into 10 raised to power 23. On calculating, we are getting the mass equal to 1.99 into 10 raised to power minus 23 grams. So, this is the mass of single carbon atom in grams. So, the other importance of mole concept is like mass of an atom, we can calculate the mass of one molecule of the substance. So, by formula mathematically mass of one molecule of substance will be equal to gram molecular mass divided by Avogadro's number. So, we can have this in the numerical form, that calculate the mass of single molecule of hydrogen. Now, molecular mass of hydrogen, because it is H2, it contains 2 atoms. So, its molecular mass is 2 AMU, and gram molecular mass of H2 will be naturally equal to 2 gram, because once again that molecular mass expressed in grams is called as gram molecular mass. So, this gram molecular mass is the mass of 1 mole of molecules, and 1 mole of molecules is equal to Avogadro's number. So, we can equate 6.023 into 10 raised to power 23 molecules of hydrogen will have mass equal to 2 gram, and a single molecule of hydrogen will have mass equal to 2 upon Avogadro's number. So, this is equal to 3.3 into 10 raised to power minus 24 gram. So, this is the mass of single molecule of hydrogen H2. Similarly, you are to calculate the mass of single molecule of water. So, first of all you must know the molecular mass of water. Molecular mass of water H2O. H2O is having molecular mass 2 into 1. 2 is the number of hydrogen atom, 1 is the atomic mass of hydrogen. So, 2 into 1 plus 16, 16 is the atomic mass of oxygen. So, 2 plus 16 comes out to be 18 AMU. Gram molecular mass of water will be equal to 18 gram, and this is equal to Avogadro's number. You can have equation 6.023 into 10 raised to power 23 molecules of water will have mass 18 gram. Single molecule of water will have mass 18 upon Avogadro's number. So, this comes out to be 2.99 into 10 raised to power minus 23 gram. So, this is the mass of single molecule of water in grams. The third application of mole concept is to calculate the number of atoms. Previously, we have calculated the mass of the atoms. Now, we can calculate the number of atoms in a given mass of the elements. So, number of atoms in a given mass of the element, that is equal to mass of element in grams divided by gram atomic mass into Avogadro's number. So, you can understand it by taking this example, that calculate the number of atoms in 20 gram of calcium, whose atomic mass is 40, atomic mass of calcium. So, we can solve it by this way. Atomic mass of calcium is 40 AMU. Gram atomic mass of calcium, that is equal to 40 gram. Now, 40 gram contains how much number of atoms? 6.023 into 10 raised to power 23 atoms. So, 1 gram will contain Avogadro's number divided by 40, 20 gram of calcium will contain 6.023 into 10 raised to power 23 upon 40 into 20. So, the result is 3.01 into 10 raised to power 23 atoms. So, this is the number of atoms which are present in 20 gram of calcium. The fourth application of mole concept is